Hello everyone. Today here we have a JEE question on continuity and differentiability. The question goes as, let f be a function from set of real numbers to real numbers defined as f of x equals to lambda into modulus of x square minus 5x plus 6 divided by mu into 5x minus x square minus 6 if x is less than 2, e to the power tan x minus 2 divided by x minus greatest integer function x if x is greater than 2, and it is mu if x equals to 2. Okay, where x is greatest integer function. If f is continuous at x equals to 2, then what is the value of lambda plus mu? Okay, so they have given here the function is continuous at x equals to 2. By definition, I will definitely know that if the function is continuous, then at x equals to 2, the left hand limit will be equals to right hand limit. That is, f of 2 will be equals to limit of f of x as x tends to 2 from right hand side, left hand side, and limit of f of x as x tends to 2 from right hand side. Now first, if f of 2, okay, so let us find first f of 2 from the definition. If x equals to 2, f of x is defined as mu. Let this is equation 1. Now we'll take LHL value. What is LHL here? Limit as x tends to 2 from left hand side f of x. If it is approaching from left hand side, what is the function? X square minus 5x plus 6 divided by mu into 5x minus x square minus 6. Okay, so if you apply the limit directly here, you might first we will solve this further. Now this can be written as x tends to 2, okay, lambda. If you take the factors here, it would be x minus 3 into x minus 2. Is that correct? The factors of this would be x minus 3 into x minus 2, and in the denominator we have mu into, okay, here I'll get 3 minus x into x minus 2. Okay, now since see here the x is approaching 2 from left hand side on the real line. Okay, if x is approaching 2 from the left hand side, that is from the negative part. Okay, so from the negative part, it is if it is approaching the values which are less than 2. If I take the values which are less than 2, this will be minus and this will be minus, correct? Because to apply the limit, I have to remove the mod and input could be plus or minus. Now, if x is approaching from left hand side, this would take minus and this would take minus. So, minus into minus is plus. That means this opens with the value of positive x minus 3, x minus 2, and whole thing divided by mu into 3 minus x into x minus 2. Now this is exactly same. Now this is again same, only with respect to minus. If I take, this can be written as x minus 3. That's why I'll get the value of LHL as lambda by mu. Okay, fine. So we got one relation. Similarly, we will find for RHL. What it says, limit of f of x as x tends to 2 from right hand side. Okay, and from right hand side, if x approaches 2, what is the function defined? E to the power tan of x minus 2 divided by x minus greatest integer function x. Okay, so this is e to the power x. Now you observe a little bit here. X minus greatest integer function is always fractional part of x. Is that correct? It is always fractional part of x. So what this function becomes now? Tan x minus 2 divided by fractional part of x. Now x is approaching 2 from right hand side. So if I take any value which is greater than 2, okay, say if I take 2.7, what I'll get here? 2.7 minus 2 is 0.7 divided by 2.7. Okay, so the fractional part is 0.7. So you can see that somewhat I'm getting in the form of tan theta by theta, because this value and this value is becoming same. And we know one theorem, if tan theta by theta, as theta tends to 0, it is equal to 1. Am I correct? Now here, since x, what I have, tan x minus 2, and this value is becoming same as that of x tends to 2, and here I have limit as x tends to 2, that is nothing but x minus 2 tends to 0. So from this theorem, I will definitely come to know that this is equal to 1. So RHL is equal to, if I apply the limit, e to the power 1, which is equals to e. Therefore, now since it is a continuous function, therefore from equation 1, mu equals to left hand limit is equal to right hand limit. Is it correct? Okay. So from this, one by one what we can write here is, one relation I can write, from this relation I can write mu square is equals to minus lambda. Is it correct? Also, these two are equal to each other. So, E equals to mu. Yes, we are trying to find the value of what? Lambda and mu here, because we need lambda plus mu. So, again, since E is equals to mu, so this becomes E square equals to minus lambda, or lambda equals to minus E square. So we got the value of mu, we got the value of lambda. So lambda plus mu is equals to, lambda is minus E square plus E. Or what we can take common here, 1 E we can take common. So what remains here? Minus E plus 1. So what is your answer? E into minus E plus 1, which is option A. Thank you.